Okay, so we have Bree was at the spot where you were at window 8 and board 4. Michael, you were at, I'm going to say Mike. I should have put Mike as the midpoint because it's M. But anyways, so Mike, we're not going to call you Mike right now. We're going to call you George. Just so it's not an M. I don't want to mislead folks. Okay, M. And then Vinny was 4.5, B, board 5, right? Okay, this was the midpoint. This was the midpoint. Okay, now let's talk about the first thing we did when we did that was we kind of oriented him in relationship to the window. Okay, we gave him a thing. When we deal with coordinate graphs, okay, coordinates, you guys have seen those before and you might have jumped on to what I was doing. But we call them X's and Y's instead of windows and boards. Okay, and we put it all in relationship to the origin. In this case, we're all in the first quadrant. So 4, 5, 6, 7, 8. And we say windows, 8 X's and boards were Y's. So we get 8, 4, and then George would have been at window 1 and board 6. Okay, and then when we said Vinny being the midpoint at 4.5, board 5. Okay, and graphically that makes sense. Bree, George, and Vinny. Okay, graphically that makes sense. It's being in the middle, right? When we're going to deal with this in geometry, we actually need to be a little bit more specific, okay, and a little bit more regimented on how we actually calculate where that midpoint actually is, okay, on the Cartesian coordinate grid, okay. Essentially, what we did when we did that little activity is we took the window spots, the spots where they were on the windows, okay, and you guys averaged those, right? You essentially averaged 8 and 1. You guys remember how to average things? Add them up and divide them by 2. Okay. You also average the y coordinates, or the board coordinates in our case, 4 plus 6 and divide by 2. You got 9.5, which was 4.5, and you got 10 halves, which is 5. Okay. That is the exact same spot as where a midpoint Vinny was. Okay. The issue that we have, though, is it's not always going to work because let's pretend like our classroom was a plane in space. That plane goes on forever, okay? Goes on absolutely forever. So it's not always going to work to look at it graphically or visually and then be able to determine that where you could like count where it is, you know what I mean? Which is actually how we placed Vinny in the classroom first. We kind of looked at where they were and we kind of split the difference and moved them around to make sure he was in the right spot. But that's not always going to be the case when we turn around and do it geometrically because you might not be able to see the picture. It might be too big. Or when you try to graph it, you might not graph it correctly and make a mistake there. Okay? So that might be pretty difficult. Instead of doing that, we can turn around and just write an algebraic equation for it based on what we do, based on what we just did. We're going to turn it into a generic equation. Okay, so if I turn this into a generic equation, what do we do when we don't know a number in math and we want to just make it generic and let it be open? A variable, yeah. And we're actually going to pick variables that are pretty, that are very specific and have a lot of meaning to them instead of just picking like A, B, C, D, which we could do, but that's not going to give us a lot of information. Okay, if we say A, B, C, D. If instead we say, like generically, okay, we have a point in space. Instead of calling it AB, point AB, we call it X1, Y1, which just means that the X1 is an X coordinate because it's an X. The Y1 is a Y coordinate because it's a Y. And because they both have ones in them, it's a part of the same point, point 1. Does that make sense? Why we're picking those? Hopefully, instead of A and B, because that doesn't tell us. We're also going to put our second point. We're going to call it x2, y2. Why? So that we can kind of tell that, okay, x2, y2 with the 2s, that's at point 2. So that matches with that. And x and y so that we know it's an x coordinate or a y coordinate instead of like C and D, which is kind of ambiguous. Okay? What we did here, instead of 8, we had x1, we could say. And instead of 1, we had x2. And then we divided it by 2. And then instead of 4, we had y1, added it to y2, and we divided it by 2. Okay, and that's actually our formula for our midpoint in space. Oops. And as an ordered pair. Does that make sense? Do you get the y on that formula? Because if you get the y on that formula, actually using the formula isn't that crazy. But if you don't get the y, it can be kind of difficult to use the formula. Also, this was the average x coordinate and the average y coordinate. Does that make sense too? That's how we built it. That's how we did it. Okay? That's in two-dimensional space. If we scale back down to one-dimensional space, if say this is point A and point B, there's no like x and y here, so it's just point A, point B, and we want point M. Okay, and those are the coordinates of those points. It would be A plus B divided by 2 would give us the coordinate of where the midpoint would be. Does that make sense? Just average the two coordinates. Okay. What I want you to do right now in your groups, I'm going to give you a worksheet. I want you to do the front of the worksheet. Just talk it over. Collectively decide. I'm going to give you a few minutes, like 5 minutes, to talk it over and work through it, and then I'm going to start walking through it with you, and we're going to start on the other page. Go. All right. On the first one, AB, the coordinate of A is at negative 12. Coordinate of B is at negative 7. So if we add those up and divide by 2, we get negative 19 over 2. You can leave it like that. But I guess in this case, it makes a little bit more sense to talk about it in terms of a decimal because we're talking about it graphically or visually. So that decimal is kind of okay there. At BC, B is at negative 7. C is at negative 2. So we write those down. We average those. So we get negative 9 over 2, which is fine to leave it like that. Or I suppose you could put it at negative 4.5 because we're doing it visually. And in order to put it on the picture, you got to know that it's like 4.5 instead of like 9 halves. It's harder to deal with. All right, C and E. C is at negative 2. E is at 10. Add them up, divide by 2. 8 over 2, which is 4. DE, which is 6 and 10. Add them up, divide by 2. 8. All right. Again, a recommendation to you guys while you're doing these is just write this out. I know that's kind of a pain, especially if you can do it really fast. But write that out because if you make a mistake, like accidentally, if you got negative 17 over 2, hypothetically say you got negative 17 over 2 for that one. Hypothetically say you got negative 17 over 2, and you wrote this first step that I highlighted. I'm going to give you, half credit for it. But if you just wrote negative 17 over 2, I'm not going to give you any credit for it. It'll be totally wrong. That makes sense. I'm not going to guess what you made as a mistake. Okay, anyways, on JK, you got to know like where these points are to talk about them as far as their coordinates. This is at 2, 4. That point's at 2, 4. Okay, and this point's at negative 4, 4. Does anybody need a conversation on how to find where those ordered pairs are? You guys okay? Anybody want me to talk it over real fast? We okay? Okay. Stop me. Come at me if you need me to explain that again, of course, as we're going through. So if you do it using the algebraic method, if you don't have a graph or like you can't draw the graph accurately, whereas the numbers are too large, you would do negative 4 plus 2 over 2. And then 4 plus 4 over 2 to find the midpoint, which would be negative 2 over 2, which is negative 1, and then 8 over 2, which is then 4. Okay, now you could do that visually. That's not a problem. But if there could be a very big issue where you can't see them on a grid, or the graph's not given to you, or it's just the numbers are just plain old too big to deal with, you'll probably want to do the midpoint formula. All right, JK, or that was JK. Now KL, so we have negative 4, 4, and we have negative 2, 2. So if we do it again, negative 4 plus negative 2 over 2, 4 plus 2 over 2. And we go ahead and simplify, so it's negative 6 over 2, which is negative 3, and then 6 over 2, which is positive 3. Okay. I'm going to do NT. By the way, a way to check this stuff, like if we're looking at KL and we want to know to check, we said negative 3, 3, 1, 2, 3, 1, 2, 3. You could graph that midpoint, the coordinate that you think is the midpoint, look at it visually and see if that looks like it's in the middle. If it doesn't look like it's in the middle, chances are you made a mistake somewhere, and maybe you want to go back and reassess what you did. Okay? Anyway, so N was at 1, 2, 3, 3, negative 1. T was at 4, negative 4. And then we do 3 plus 4 over 2, and then negative 1 plus negative 4 over 2, which would be 7 halves, which is 3.5, which is negative 5 halves, which is negative 2.5. And then 3.123 and a half, negative 2, and okay, that's in the right spot. Thank goodness. Does anybody care if I skip MT? No. Okay. Nobody likes MT. Sorry if that's your initials. Let's look at the back. Collectively as a group, I want you to take a look at numbers 1 and 2. Okay, just numbers 1 and 2. And I want you to come to a collective, cohesive, I guess that makes sense, a decision based on what you want to put on those lines. And your answers to the questions, okay? Work together as one group, as a whole, and talk it over and discuss what you think those answers are. Okay? And then we'll come back and talk about it. Go! Yeah. Okay, on a number line, the coordinate of the midpoint is the coordinate of the midpoint is the sum of the coordinates of the endpoints of the segment divided by blank. That one's really hard to understand if you don't break it apart. You can stop laughing. Here we go. Okay, 1A winds up being divided by 2. Yep. Okay, the midpoint of a segment on the coordinate plane is always written as an ordered pair. The midpoint of the segment with endpoints, blah, 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 is, what is it? 4, negative 3. Yep. State whether the statement is true or false. Number 1, the distance. Oh, yeah, by the way, see the second part, just like a lot of you forgot to do on the quiz, explain or change the word or change the underlined words if it is false to make it true. Okay? On the quiz, not the test. The distance from one endpoint of a segment to the midpoint is the same as the distance from the other endpoint to the midpoint. True? That one's true. The midpoint of the segment on a number line with endpoints negative 2 and 2 has coordinate of 0. It's false. Coordinate 0 because you add them up and divide by 2, 0. 0 over 2 is 0. The midpoint of a segment does not bisect the segment. It does bisect the segment. 100% does. That's what a midpoint does. It bisects the segment, splits it into 2 equal parts. Okay, but a midpoint is more specific than, say, just a bisector, because if you just call it a bisector, it could be an angle bisector. You know what I mean? It also refers to the fact that it's collinear with the 2 points, if you say midpoint. Okay, let's go to the back side. The last page. Go ahead and read this right now, and tell me what the problem is. Okay, think about what the problem is with this picture, with this question.
First one be 4. Oh, sorry, 5. Let's do it 5 by 5.
Okay, here's the problem. Guys, listen. Guys and gals. Here's the problem. Did you guys find the problem? Problem is that we know where the midpoint is. We don't know where the other endpoint is, right? But if you graph it, okay, remember I keep trying to tell you guys, that if you don't understand the wording of something, draw a picture that represents that something. Well, here's a picture that represents this problem. Okay, visually, if A is an endpoint, we go back and read it. If A is an endpoint and M is a midpoint, that means the other endpoint has to be somewhere down there. We know that. Okay, so mentally you know that's the case. There's actually two ways to do this problem. The first way is a visual way, and the second way is an algebraic way. The algebraic way will always work if you do it correctly. The visual way won't always work because you might graph something a little funny, or you might not even be able to put it on a graph. Okay, let's be honest. Okay, so what you really need to focus on is the algebraic way. But let's start with the visual way because I think a lot of people understand that a lot faster and easier. Okay, from A to M, if you go down, you only go down one, right? So if from M to where this other midpoint endpoint is, you go down one. So we know the endpoint has to be somewhere on this line in this section. That makes sense? That endpoint. Then we can turn around and we can find the horizontal distance of 1, 2, 3, 4, horizontal distance of 4. Then we can transfer that down here to a horizontal distance of 1, 2, 3, 4. And guess what? That's right there, perfect spot right there. Okay, that's where the other endpoint is. And you can read that 1, 2, 3, 4, 5, 1, 2, 3. So you can read that as -5, 3. Okay, and that could be your answer. That's 100% valid method of doing the problem. Okay, I'm not saying that's not a valid method. I'm saying that's harder for me to know what you were thinking while you were doing it in the event that you make a mistake. Right? If you just wrote that down, it's hard for me to know what you're communicating to me, especially if you make a mistake. If you get it right, that's one thing. But if you make a mistake, it's hard for me to understand what you're actually doing without you talking it through or writing a big paragraph. A way that I can understand it 100% without you really saying much or writing many words, okay, even if you make a mistake, is this. That's the midpoint formula. That is, that's equivalent to where the midpoint is, right? That formula gives us -1,4, hypothetically. What we also know is this is one of the endpoints, and remember x1, y1? That was an endpoint based on the formula for the midpoint. So that x1, y1 right there. So we can put 3 and 5 into those spots and fill in the rest of the stuff that we don't know and keep them as variables. So 5. And I don't know if you can visually see it, that turn around and you get one equation from that to represent the x's. The 3 plus x squared over 2 equals -1 that you can solve. Right? That's an equation you can solve. You can multiply both sides by 2. And you get 3 plus x squared over 2, not over 2, equals -2. And then -3 from both sides, right? And you get x squared equals -5. Guess what? We got the same value, which is good, because if we didn't get the same value, we'd have issues. Okay, and then we can set up another equation. Now this is a little bit more regimented, a route way to go. So multiply both sides by 2, 5 plus y squared equals 8. -5 from both sides would be 3. So we can't leave that as our answer. We have to go back to the ordered pair as our answer, because we're actually asked for an ordered pair, just like that question on the previous page. The answer to the previous page. It needs to be an ordered pair. But the reality is, there's two totally valid ways to do this. There's more valid ways to go about this, okay? But here's two primary ways. The second way, the one on the right, the algebraic way, is going to work for any case in all cases, as long as you do the algebra right. On the left, that's not going to work in every case. What happens if the numbers are too big? Like when we did the graphing at the beginning of class, what if this was at an actual plane? The plane would go on forever in all directions. So Vinny could have been in no man's land, and Bree could have been in no woman's land. And how would we? It would have been hard. As long as they're on the same plane, we could still find the midpoint. It would have been difficult. Or actually, it was George and Bree. Okay, George was in no man's land, and Bree was in no woman's land. And Vinny would have had a difficult time finding it. But if we did some calculations, we would have found it. Okay.